Hey guys, I'm going to quickly go over different types of graphs that you can use to represent data. Again, we didn't have time to go over this in class, but I just figured that it's important to tell you guys just because you need to know when to use different kinds of graphs and what kinds of graphs are going to be best for representing the data that you're, going to be collecting. So I'm just going to go ahead and share my screen so that you guys can see what I see. All right, so this is your guys' PowerPoint. Obviously, you guys have all have access to this. I remember we went over this in class, what a pie chart is. Pie chart is the easiest to understand because it is a pictorial representation of the data. It's best for representing categorical or nominal level data like our seatbelt data, how many males versus females report wearing a seatbelt and different levels of how they wear it, like seldom, some of the time, most of the time, etc. And you can see here that it's very easy to see all of the percentages add up to 100%. We've got 47% say all of the time, 21% say most of the time, 19% say some of the time, and 13% say seldom. And you can see easily that 19 plus 21 plus 13 plus 47 adds up to 100%. This is a very clear representation of all of these different parts adding up to a whole of 100%. And then we've got bar graphs. For nominal and ordinal data, it is easiest to use a bar graph. Any non-numerical or categorical data you have. So again, like I showed you guys in class, the categories or the possible values of X are shown right here on the X-axis. This is personality types between college students in a college class. We've got personality type A, type B, and type C. Again, these are discrete variables, meaning that there are no decimal points or no continuity possible between the different categories. Like I said in class, numbers of siblings you have would be considered a discrete variable because you can't have a third of a sibling, you can't have half of a sibling, you can have whole numbers only. Same thing with categorical type data. Categorical type means that again there are no decimals. You can't have a personality, 8.5, right? It doesn't make sense. So a bar graph is pretty similar to a histogram, except that with a histogram, there are no spaces between the bars. These spaces between the bars indicate, again, that there are discrete categories of variables. And then frequency we'll put on the x-axis. X-axis can be used to represent independent variables, the y-axis to represent dependent variables. So in this case, our independent variable or thing that we are changing or observing the differences between would be personality type. I'll get to sometimes you won't have an independent variable that you are looking at. You'll have a quasi-independent variable, which means that you can't change something, but you can look at differences between categories of that variable and still observe a difference. For example, like gender. You can't randomly assign somebody in a study to be male versus female, but you can still consider that an independent variable, just a quasi-independent variable, something that a researcher can't change or can't force somebody to be a different thing of or a different category of, but you can still observe differences between men and women in certain things. And for dependent variable or, observing frequency or how this changes, we'll put it on the y-axis. Sorry, there's a little bit of a tangent. There's a lot of nuance, like I said, in psychology. There's a lot of nuance that we have to observe. And just like with Likert scales, is it ordinal or is it interval? It just depends on the context in which you're using it. So again, just like we did before, we have different categories down here on the x-axis and different frequencies that we observe on the y-axis. And we can read this pretty easily. The bar graph is a pretty easy graph to read. All we do is look at the categories. If I want to figure out how many people have blue as their favorite color, I just go down here on the x-axis. I look for blue. All right, great. And then I want to see frequency. I look over here on the y-axis, go to frequency, and looks like maybe 2 people have blue as their favorite color. Pretty easy to read. Or 2, or I can at least say less than 5, right? Even if there's no ticks right here that tell me the differences between intervals. Bar graphs can look different. I'll show you in Excel, how we can construct a bar graph. Bar graphs can look different. We can accommodate multiple categories at once, which means it makes it very easy to use. It's very flexible, and for this reason, it's much more commonly used in social research than a pie chart. A pie chart can present frequencies and it can present percentages, but sometimes that's not the best way to represent the data. So bar graphs are usually the most commonly used, just because it's such a can accommodate such a wide variety of categories and represent frequencies. Very easy to read. All right, we can do the same thing when we report grouped frequencies, right? If we're looking at grades, 15 people in this sample made a 90 to a 99 on the test. 12 people made an 80 to 89. 8 people made a 70 to 79. 3 people made 60 to 69 on this test. So again, you can see x-axis, we are observing the differences between, and y-axis, the frequency. Now, graphs can very easily be misused. We have to pay close attention to how we are constructing our graph and how that best represents the data. Sometimes we need to make sure that our data at first glance is not being misused. So take this, this data from an election. So the mayoral candidate's graph, the candidate that is running to be elected, is representing the number of homicides that occurred the year the current mayor was in office, from 2016 to 2017 to 2018. So here the x-axis would be time we are observing changing. And number of homicides on the y-axis, the thing that is changing as a result of time. And what do you notice about this graph? It looks like a very big difference, right? From 2016 to 2017, it looks like the number of homicides has, tripled? Same thing with 2018. It's still going up at a pretty alarming rate. But again, look at the y-axis. The y-axis doesn't start at 0. It starts at 215. And the absolute highest it can go right up here is 230. So it looks like the homicide rate has tripled from 2016 to 2017, but really the number of cases only went up by like 8. Now, the mayor's graph is a much more accurate representation of the data. Its y-axis increment goes up by 200s. So from 2016 to 2017 to 2018, it hardly looks like the homicide rate is increasing at all, which it's not. But again, if your increments in the y-axis goes up by 200s, so it goes from 200 to 400 to 600, then that's also not going to give a really good representation of the data. Even though the homicide rate isn't changing by much, we still need people to look at the graph and say, that it is changing. We need to be accurate with how we represent ourselves and how we represent our data. So really, Maybe we could have the number of homicides on this graph, the maximum number of homicides, be 300. And our graph goes up by 100s or maybe by 50s. That way, the intervals with which the graph increases by on the y-axis gives a little bit more room for nuance in between these graphs, right? In between the years on the x-axis. So again, we not only need to be careful with how we are constructing our graphs to represent our data, but also be critical about how we're reading data, because over here on the left, this graph right here, we could very easily misread that. Now, histograms are used to display continuous variables. They're just like bar graphs, only there's no spaces in between the bars here on the graph. Now, an example of a continuous variable pictured here is GPA. Now, the histogram is constructed like this to emphasize that there is continuity across these categories, that there are decimal points, that it doesn't go, you can't go from a 1 GPA and then straight to a 2 and then to a 3, right? You can have a decimal point in between those. You can have a 2.1 or a 2.2 or a 2.3. So a histogram is meant to show that there's no stepping stones. It's like a continuous curve, right? Histograms are also sometimes called frequency distributions, and it's for this it's one of the easiest ways to show a frequency distribution. The height again being frequency, and the x-axis listing the values of x. Or you could do a block histogram. You create a stack of blocks like a kindergartner would, each block representing one individual. So you don't have a true y-axis. The y-axis is, you're creating the illusion of a y-axis by using the blocks to represent the frequency count. So even though there's no y-axis, we can still read this, right? If you want to know how many people in this sample got a score of 4, all you need to do is go over to the x-axis, find 4, which is your score, and then count 1, 2, 3, 4. 4 people got a score of 4 because there's 4 blocks. Pretty easy, right? Again, we have to be discerning on how we use this. It would be pretty difficult to make a block histogram if you had a sample size of 1,000 people and you wanted to represent the score people made on a 100-point exam. So maybe you had one person get 100 and then one person get 99 and then 0 people getting 98 through 92. So the small variation of possibility of X scores and very low frequency or lower sample size is probably the best way to use a block histogram. We could also do a frequency polygon. Now, this is just like the block histogram, but without the blocks. We are making basically a scatter plot or a line graph, or we're drawing a line from between each of the scores. So even if you don't have a frequency, say nobody got a score of 4, we would still make a dot down here at frequency equals 0, and we would still connect everything. It uses the continuous line to indicate frequencies. Now, again, we may use this in certain situations to represent data accurately. We just need to be discerning in the ways that we use it. In some cases, it may make no sense to have a frequency polygon. And it may be very hard to read if we use a frequency polygon, again, in situations where we have a very large sample size and a very large range of X scores. So right here, you already have resources in Canvas. Dr. Corsi has amazing YouTube videos on how to use Excel and how to make notations and formulas in Excel. And also, if you go to like Microsoft, they'll have lots of tutorials on how to use Excel. But within the context of your activity for this week, let's do on Friday, I'm going to go ahead and show you how to do some basic functions in Excel. So data in Excel arranged in rows and columns. So for example, right here, you've got your rows, 1, 2, 3, 4, 5, 6, 7, 8, etc., and your columns, A, B, C, D, E, F, G. So your first row is usually going to be your variables. First row right here, we've got participants, gender, age, music, coffee, exam 1 and exam 2. Those are our variables, and underneath each of those variables are our data points. So the rows represent individual participants or cases. So you've got, in this column here on this picture, patient number, 1, 2, 3, 4, 5, 6, 7. Same here, right here, participant number 1, 2, 3, 4, 5, 6. Now I'll show you how to do a frequency count real quick. We can use the formula COUNTIF to count these nominal level variables. So I've already done it for you right here. We use COUNTIF. So I'll show you how to type it in here. We use the equal sign, COUNTIF, and then in parentheses, it'll give you a little pop-up right here. COUNTIF range, comma, criteria. So first we need to input the range. What is the computer, or what cells is the computer going to use to calculate this data? So we want column B, we want it to count everything in column B, but I'm going to go ahead and put in a particular range of cells. We want everything from B2 to B7. So how I'm going to put it in the computer is B2, right? So it selects it, or it's already highlighted this cell right here, B2. And then we use the colon, B2 to B7. All right, so see, it's highlighted that range of cells right here. Now it's going to count everything inside of this range. All right, then we put a comma. It's range, comma, criteria. We're on to the criteria. Put the criteria in parentheses. Or not in parentheses, in quotation marks. So put the criteria in quotation marks. We want to count every participant in here that is male. So put M in quotation marks and then close the parentheses, okay? So just press enter, it's gonna do a count. So the computer has counted 3 instances of that, that name or that criteria within the data. Pretty cool, right? So we can do the same thing for a music taste, right? So I've done the same here for a music taste. Now, this looks a little different because I am counting music and not gender. So I've moved over to another column. I'm doing from column D. So we're going from D2 to D7. I want the computer to count every instance that pop comes up. So pop comes up 1, 2, 3 times. And the formula here reflects that. It's counted 3 instances of pop. Pretty cool. You can also use Excel to create graphs. You can select any data and labels that you want to use. So right here, we can go to Insert. And we can choose any kind of chart that we want. The chart is completely up to you. But again, now that I've taught you how to use charts, use a chart that makes sense. So let's see. Let's do a bar graph. Let's just choose something like this. So I want let's select these two columns. Now let's select coffee and gender, and let's get rid of this notation. Let's get rid of these counts here. So let's select gender and coffee. Go to insert again, charts. Okay, well, it doesn't look quite right. Hold on. Okay, insert. Now this worked earlier. Why is it being weird? Well, I'll just take this time to show you guys. You can make a pie chart. You can make a line graph. You can make a bar graph. You can make a tree map, whatever the heck that is. You can make a histogram or a box and whisker plot, or you can make a scatter plot here. I'll also give you recommendations. I don't know if this is exclusive to every every version of Excel. Okay, let's just do something easy. Let's do participant number and amount of coffee. There we go. So it shows us that participant number 1 drank 0. Participant number 2 also drank 0. Number 3 drank 3. Number 4 drank 2. Number 5 drank 1 cup of coffee. And number 6 drank 2 cups of coffee. Right? Super duper easy. Now, now and last thing I want to say is just make sure that when you report frequency, report it in APA format. But there's usually no strict formatting rules for reporting frequencies. So don't worry about the fact that it says APA. There's not really the American Psychological Association doesn't really put a lot of restrictions on reporting frequencies as long as you're not biased or eliminating outliers or altering the data in any way. So what about your guys' activity? So your guys' activity looks a little bit like this. So number 1, I'll just go over number 1 with you so you remember what I talked to you guys about custom sort and how to use it. I'll demonstrate how to do it because I know it was a little quick at the end of class yesterday. So which 3 countries have the highest number of COVID-19 deaths? Use a custom sort. All right, so let's go over to COVID-19 death rates. And let's highlight B, C, and D. So we're going to use a custom sort. Shrunk it too much. All right, we're going to use a custom sort. So you go over here, all the way to the right, sort and filter. You go right here to custom sort. So you sort by, let's see, what is it? Highest death rate, highest number of deaths. All right, so you go column B or column D, and you want largest to smallest because you want to see the largest number of deaths. Okay. It's going to sort by who has the highest number of deaths. So you go right here, USA, highest number of deaths. And it's actually rearranged the country names and number of confirmed cases as well. Now, if you don't want your data to get massively messed up, you need to select all of the columns that have a data point in it, because otherwise, if you sort just column D by number of deaths, it's just going to rearrange column D. So you're not going to know who has the highest number of deaths in this case. Only if you highlight all of them, it sorts each country by number of deaths. All right. So which three have the highest number of deaths? So if you sort by number of deaths, USA, Brazil, and India. All right. Pretty easy, right? So again, if you have any questions, just let me know. I am available by email. Even though I'm not going to be in class, you can still reach out to me, ask me a question. Just do it before the due date. All right. So thank you guys for watching. I appreciate it. I will see you guys all next